whiteboard and let's start with reactions of alcohols. Sorry, reactions of aldehydes and ketones. Reactions of aldehydes and ketones. So what reactions we can do on aldehydes and ketones to make product? To make what type of products we can make by using aldehydes and ketones? Well, aldehydes and ketones undergo oxidation and reduction reactions. So again, we are continuing the same topic that we learned in chapter 13. In chapter 13, we learned it, right? So aldehydes and ketones undergoes oxidation and reduction reactions. We learned about oxidation and reduction in chapter 13. So what happens for aldehyde? So let's take a simple aldehyde. If I take an aldehyde, this is my alpha carbon, and I have a hydrogen on alpha carbon. So aldehyde undergoes oxidation. Oxidation is adding oxygen and removing hydrogen. So I will form, please look at here, I'm going to add oxygen onto this. I'm adding oxygen. Please look at here. I'm adding oxygen and moving this hydrogen from here onto the oxygen. Everyone see that? Now, if you look at aldehyde and if you look at carboxylic acid, clearly you guys can see the number of bonds of alpha carbon with oxygen is increasing. Here, the alpha carbon is forming only 2 bonds with oxygen. Here, alpha carbon is forming 3 bonds with oxygen, 1, 2, and 3. So clearly, you guys can see the number of bonds increased. So this process is called oxidation. So aldehydes, can I generalize like this? Aldehydes on oxidation produces what? Corresponding carboxylic acid. They produce corresponding carboxylic acid. I want everyone to memorize this. If you take an aldehyde on oxidation, it produces corresponding carboxylic acid. Now, what happens if I take a ketone? So let's take a simple ketone. Let's take a simple ketone. Is it possible for ketone to undergo oxidation? Let's check this. Where is my alpha carbon? This is my alpha carbon. This is our alpha carbon. And we don't have any hydrogen on alpha carbon. Everyone see that? Because in order for alpha carbon to undergo oxidation, it needs to contain hydrogen. It needs to lose hydrogen. But there is no hydrogen on this alpha carbon in ketone. So the product is no reaction. So ketones doesn't undergo oxidation. Ketones doesn't undergo oxidation. So let's define what is oxidation and what is reduction. Oxidation is addition of oxygen. Basic definition is addition of oxygen. Now, what is reduction? What is reduction? Reduction is exactly opposite. Addition of hydrogen. Now, please look at here. Please look at here. Aldehydes on oxidation will give carboxylic acid. Ketones on oxidation will give nothing, no product, because there is no hydrogen on carbonyl carbon. On carbonyl carbon. Let's do some example problems. Let's do some example problems. Can I erase this? Please send me a chat message. Can I erase this? Okay. Now, let's take this ketone. What is the product of this molecule? What is the product? Please send me a message. You're oxidizing a ketone. This is your alpha carbon. Do we form any product? Yes or no? Do we form any product? No reaction. Yes, no reaction. Why there is no reaction? Because if you look at this carbon doesn't have any hydrogens. This carbon doesn't have any hydrogen to remove hydrogen. So oxidation is addition of oxygen. Yes, there is no hydrogen there, so no product. No product. Now, Draw the product for this. Draw the product for this. This time I gave you guys aldehyde. Clearly you guys can see there is a hydrogen to lose, and this is your alpha carbon. What is the product? Please look at here. So this is my alpha carbon. I'm adding oxygen to it. I'm adding oxygen to it, and then I'm moving this hydrogen onto this oxygen, COOH. Everyone see that? COOH. COOH. Now let's look at the reduction reactions. Now we know how to do oxidation. Now let's work on reduction. We know how to work with oxidation. Now let's work on reduction. So what is reduction? Reduction is addition of hydrogen. So if I take aldehyde, if I take aldehyde and if I add hydrogen, what is the product? If I add hydrogen, what is the product? So let me show you guys exactly how to add hydrogen. Can I write aldehyde like this? This is aldehyde. I'm just rearranging it to show you guys. I'm just putting this hydrogen down on the carbon. It's still on the carbon. I'm just placing it on the bottom so that I can show you guys how to add this hydrogen. Now I'm going to place this hydrogen like this. Now you guys can see this alpha carbon gets one hydrogen, and this oxygen picks up the other hydrogen. So when they do this, what happens to the double bond? The double bond becomes a single bond, and this bond is broken. This bond is broken. So look at the product. CH3C, please look at here, CH3C, double bond becomes a single bond. On the top, you have OH. So clearly you guys can see this oxygen picked up this hydrogen to form OH. Now on this carbon, you have hydrogen and this hydrogen, so CH2. What type of alcohol is this? So when you do reduction, you form alcohol. And what type of alcohol is this? Clearly you guys can see this is a primary alcohol. It's a primary alcohol. So can I make a statement here? Aldehydes on reduction. So I'm going to show reduction like this. That means I'm adding hydrogens to form corresponding primary alcohols. Corresponding primary alcohol. So I want everyone to remember this equation. Aldehydes on addition of hydrogen forms primary alcohol. You guys can see I took aldehyde CH3, C double bond OH. I already have H here. I'm adding hydrogen, H2. When I did that, what happens? This oxygen is picking up this hydrogen, and this carbon is picking up this hydrogen to form primary alcohol. Why this is a primary alcohol? Because the alpha carbon, which is this, is attached to only one other carbon. So this is a primary alcohol. Please write down this. So aldehydes on reduction will give you primary alcohol. Now what happens to ketone? So let's look at ketone. Can I erase this? Can I clear this? What if I take a ketone? So let's take a ketone and add hydrogen. Adding hydrogen is reduction. So what I'm going to do is I'm going to take alpha carbon and I'm looking at oxygen. I know these two are the ones which are going to get hydrogens. So I'm going to rearrange a little bit to show you guys exactly how this happens. Can I write the ketone like this? The CH3 is still attached to the carbon. Now I'm going to place hydrogen like this. Because when you're adding something, the addition always happens on the double bonded atoms. The double bond is between carbon and oxygen. So this carbon will pick up that hydrogen. And this oxygen will pick up that hydrogen. Same process. CH3 COH, because this oxygen picked up this hydrogen to become OH. Now the double bond became a single bond. This carbon is picking up what? That hydrogen to become CH. Now this carbon still contains that CH3, so I'm going to place the CH3. So what type of alcohol is this? This is a secondary alcohol. Clearly, you guys can see ketones on reduction will give you guys a secondary alcohols. So can I summarize this? Can I generalize this? If I take a ketone, on reduction, forms secondary alcohol. Forms secondary alcohol. So these are the reactions of aldehydes and ketones, oxidation reduction reaction. We have one more reaction we need to learn, but let me summarize the whole oxidation and reduction from chapter 13 and chapter 14. Chapter 13 and chapter 14. I'm going to combine oxidation reduction reactions from chapter 13 and whatever we learned today, chapter 14. Okay, let me clear all this. So please look at here. I'm going to summarize summary of oxidation reduction reactions. So please look at here. So if I take a primary alcohol, on oxidation, what we learned in chapter 13, primary alcohols undergoes oxidation to give aldehyde. And today what we learned, aldehydes also undergoes oxidation to give carboxylic acid. You guys can see how I'm combining this. Now, you guys can clearly see we are going from primary alcohol. Primary alcohol on oxidation will give you guys aldehyde. Aldehyde on oxidation will give you carboxylic acid. We saw that today. Aldehydes on oxidation giving carboxylic acid. If going from left to right is oxidation, which is loss of hydrogen or gain of oxygen, what about going from right to left? Going back is reduction. Going back is reduction. So we just saw aldehyde on reduction will give you what? Primary alcohol. We just saw that right now. Aldehyde on reduction will give you primary alcohol. We just saw that. Carboxylic acid on reduction will give you aldehyde. Aldehyde on reduction will give you primary alcohol. It's going from left to right is oxidation. Going back from right to left is reduction. If you take a secondary alcohol, on oxidation, going from left to right is oxidation, will give you ketone. We saw that in chapter 13. And we saw ketones doesn't undergo any oxidation. No reaction. We saw that today. But what about ketone going back? Ketone going back is reduction. So we just saw that right now. Ketone on reduction will give you secondary alcohol. Now, if you have a tertiary alcohol, tertiary alcohols doesn't have any reaction. No reaction for tertiary alcohols because of lack of hydrogen on alpha carbon. Because of lack of hydrogen on alpha carbon. So this is the whole summary of oxidation reduction. If you guys remember this table, you can predict any product or draw any product. Please copy this page. Okay, now let me apply this table to solve a problem. Let's take this compound. Let's say they gave you guys like this, plus H2, what is the product? If you guys are looking at like this, you guys are confused. How I can use this table to draw a product? Please look at here. What compound is this? What compound is this? C double bond OC. What compound is this? This is a ketone. You need to analyze like this. This is a ketone. To this ketone, we are adding hydrogen. If you're adding hydrogen, that means what process is this? Ketone adding hydrogen to ketone is what? Addition of hydrogen is what? Reduction. So immediately you are thinking about this table and you are thinking, where is my ketone? Here is my ketone. My ketone on reduction, which is going back, reduction is always going back to left, forms secondary alcohol. So all I have to do is draw the secondary alcohol of this ketone. So I'm going to take the same compound, I know I have to draw alcohol just to draw alcohol. That's it. This is your product. I'm just showing you guys how to use this table. You have to know what is primary alcohol. You need to know what is the secondary alcohol. You need to know how aldehydes look. You need to know how ketone looks. You need to know how carboxylic acid look. You need to know that to draw these products. Everyone see how I'm using this table? Now let's take another example. Can I erase this equation? I'm just showing you guys how to analyze this. If I can erase it, please let me know. Now let's say we got this. What is the product? Now I'm analyzing this. Okay, I'm adding hydrogen. That means reduction. So what is a functional group on this? I'm clearly looking at, I have a benzene ring. I don't see any benzene ring in my summary. So what is this functional group? What is this functional group? C double bond OH. What is that functional group? Aldehyde. So clearly this is aldehyde. I have aldehyde and I'm adding hydrogen. So immediately you have to think aldehyde on reduction will give you what? Primary alcohol. Primary alcohol, how I can make primary alcohol out of this? Please look at here. Benzene ring is going to be benzene ring. Clearly we know C double bond O becomes COH. Now, if this becomes COH, because we need alcohol, so I'm placing OH. Now, how many hydrogens I can place on this carbon? Because this carbon is already forming 2 bonds, remaining 2 bonds has to be hydrogens. That's it. That's your primary alcohol. I'm not even thinking, all I'm doing is using this summary to draw the products. Everyone see that? Now, I'm going to erase this. Let's do one more example. Draw the product for this. Now let's analyze this. Clearly they are saying oxidation. Clearly they are saying it's oxidation. And I'm looking at this ketone. This is ketone. How do I know this is ketone? C double bond O, C. So immediately I'm thinking ketone on oxidation, there is no reaction, so no reaction. Now let's solve some problems from your textbook. Please open page number 507. Page number 507. 14.19. 14.21. No, not 14.21, sorry. 14.19. 14.20. And 14.23. And 14.24. These are the problems we are going to solve. Page number 507. 14.19. 14.20. 14.23 and 14.24. So the way we are going to solve these problems is I'm going to give you guys 5 to 7 minutes to solve each problem, and then we'll go over it. If you guys have any questions, I can solve it on the whiteboard. So let's start with 14.19. You have 7 minutes to solve this. You have 7 minutes to solve 14.19. Okay, do you guys have any questions on 4.19? Do you guys want me to solve any problem? Do you guys want me to solve any problem on 14.19 or you need more time? Do you guys need more time on 14.19? Please respond. Okay, if you're done with 14.19, do you guys want me to solve any problem? Anyone? 14.19. Are you guys able to use this table to draw the products? Okay, now let's move on to 14.20. Let's take 5 to 7 minutes. 14.20. 5 to 7 minutes. 14.20. Please solve 14.20. Yes, carboxylic acid is different from alcohol. Please look at here. Alcohol is this C carbon attached to OH. This is alcohol. Carboxylic acid is this carbonyl carbon attached to OH. That's the difference. When a simple carbon is attached to OH, it's alcohol. When carbonyl carbon is attached to OH, it is carboxylic acid. Okay, do you guys want me to solve any problem from 14.20? Do you guys want me to solve any problem from 14.20? Please let me know. Okay, B, let's solve B. So first let's draw 3-methyl butanone. But means 4 carbons. 3-methyl butanone. This is 3-methyl butanone 1. That's a 3-methyl butanone. And they're asking you guys to do what? Product of oxidation. So clearly it's an oxidation reaction. Now, what type of functional group is this? Is this aldehyde, ketone, alcohol? What is this? This is ketone. How do I know this? Carbon, carbonyl carbon, and carbon. So this is a ketone. Where is my ketone? Ketone is here. Ketone on oxidation, no reaction. So no reaction. $14.20. Any other questions? 14.20. Any other questions? Okay, let's move on to 14.23. 14.23. You have 5 to 7 minutes to solve this. Please do that. 14.23. Okay, any questions on 14.23? 14.23. If you have any question, please let me know. I can show you on whiteboard. Okay, let's solve B. So you just have to draw acetone. Acetone is a common name. Acet is CH3 C double bond O. One is a ketone, so it's CH3. This is acetone, and we are doing reduction. Acetone on reduction. Because acetone is a ketone, we know ketone on reduction will give you secondary alcohol. It's a alcohol. So I'm not even thinking about it. I know how the alcohol looks. Double bond disappears, becomes a single bond with OH. COH is alcohol. And this carbon gets hydrogen. CH3. I'm adding one hydrogen on the carbon, one hydrogen on the oxygen. It's a secondary alcohol. Any other questions on 14.23? 14.23. Any other questions? Okay, let's move on to 14.24. You have 5 minutes to solve this. 14.24. Let's move on to 14.24. 5 more minutes. Okay, any questions on 14.24? 14.24. Any questions? Do you guys want me to solve any problems? Okay, so let's see. Let's solve C. Let's solve C. So the structure for pentanol 3-chloro. This is pentanol 3-chloro. You guys can see I have 5 carbons. 1, 2, 3, 4, 5. And I'm doing reduction. So reduction is here. This is aldehyde. Clearly you guys can see this is aldehyde. On reduction will give you primary alcohol. Will give you primary alcohol. So please look at here. That's my corresponding primary alcohol. I still have 5 carbons. Please look at here. 1, 2, 3, 4, 5. And that's the OH. Double bond O becomes OH. That's it. Primary alcohol. Now let's look at 14.24b. Let's look at 14.24b. So first we need to draw formaldehyde. What is form? Form means, I told you guys when I'm doing aldehydes, form means HC double bond O. Form, acet, propione, and butyl. I told you guys to memorize the structures. So this is form. Aldehyde is carbonyl attached to hydrogen. So this is your formaldehyde. Formaldehyde on reduction. Well, aldehyde on reduction will give you primary alcohol. So all I have to do is change that to primary alcohol. H, COH, because alcohol means COH. Now this carbon is already forming only 2 bonds, so the remaining 2 bonds will be hydrogens. So H, CH2OH, or you can simply write like this. Any other questions from 14.24? Any other questions from 14.24? Yes, it's a simple alcohol, ma'am. It's a simple alcohol. You need another carbon to be a primary alcohol, but in formaldehyde, you have only 1 carbon. In formaldehyde, you have only one carbon, so I have only one carbon in the product. It's not a primary alcohol, it's a simple alcohol. It's a simple alcohol. The basic idea is you're forming alcohol as a product. This is a simple alcohol. You're right. This is not a primary alcohol. Okay, let's move on to the next topic. I'm going to clear all this. So this is the last topic for our chapter. Formation of hemiacetols and acetols from aldehydes and ketones. This is the last topic for this chapter. Formation of hemiacetols and acetols. Formation of acetal and hemiacetal is the concept for last chapter. How do we make from aldehydes and ketones? Because first I'm going to define how to identify hemiacetal and acetal. How to identify hemiacetal and acetal. So please look at here. What functional group is this? Alcohol. And what functional group is this? If you're looking at COC, COC is ether. And COH is alcohol. COH is alcohol. So what is hemiacetal? Please write down. So you guys can see you have a carbon, it's the same carbon. This is the carbon which contains alcohol and ether functional group on it. That's called hemiacetal. So any carbon that is bonded to alcohol and ether, it contains alcohol and ether, is called hemiacetal. This is acetal. This is hemiacetal. Hemiacetal is unstable. So what happens in nature is this hemiacetal immediately converts into acetal. So what is the difference between acetal and hemiacetal? If you're looking at this carbon contains ether, and on the top also it contains ether. So please write down the definition for acetal. I'm going to give you guys some practical examples because these compounds has some practical applications. So the carbon, if a carbon contains alcohol and ether, then it's called hemiacetal. If a carbon contains two ether groups, then it's called acetal. Well, commercially, acetals are used to produce vitamins, dyes, medications, and perfumes. So they are used these acetals as a starting material to make vitamins, dyes, medications, and perfumes. For example, I would like to erase this. If you guys are done, I would like to show you guys some structures, some commercial compounds, like rose acetal, pamplemousse acetal, uh, and so on. If you guys are done, please let me know. If you guys are done, please let me know. Now let me draw rose acetal. This compound is called rose acetal. So let's analyze this, why this is acetal. Please look at this carbon. This carbon contains ether on this side, and this carbon also contains ether on the other side. So this is acetal. That's how we identify it. And this is called rose acetal. So this compound is also acetal. Please look at this carbon. This carbon contains ether on this side and ether on the same carbon. So this is acetal, and this compound name is so rose acetal is used to give that fruity and woody fragrances. I don't know if you guys ever smelled perfumes. to give this fruity and woody fragrances to perfumes. This pamplemousse acetal is the flavor of grapefruit. It is a flavor of grapefruit comes from this acetal. I'm just giving you guys a couple of applications of acetals. You can expect a question on acetals in the final exam. You can expect a question on acetals in the final exam. I'm going to show you guys how to make these acetals and hemiacetals from aldehydes and ketones right now. So let's look at here. If you have an aldehyde or ketone, it doesn't matter. And if we just add one alcohol, I'm generalizing this reaction for you guys so that you guys can see what I'm going to do. You will form hemiacetal. As I told you guys, this hemiacetal is unstable. So what it does is it combines with another molecule of its alcohol. It's unstable. So it combines with another molecule of alcohol to form acetal. This is exactly what happens. This is the whole reaction here. If you have an aldehyde or ketone, when you add alcohol on aldehyde or ketone, what happens? When you add alcohol on aldehyde or ketone, you form hemiacetal. But that hemiacetal is unstable. So what it does is it immediately combines with another molecule of alcohol to form acetals. So can I make a statement here? Hemiacetals and acetals are made from aldehydes and ketones by adding alcohols. By adding alcohols on them. By adding alcohols on them. Now let's take an aldehyde, or it doesn't matter. You can take a ketone. I'm going to take a simple one, simple aldehyde. This is aldehyde. How do I know this is aldehyde? Because carbonyl is attached to hydrogen. Or if you contain CH3 here, it's ketone. So it doesn't matter if you take aldehyde or ketone. Now I'm going to add alcohol. So please look at here. This is alcohol. I'm just writing alcohol like this. CH3OH. This is alcohol. Now I'm going to add alcohol onto this carbonyl. So what happens is this oxygen will pick up this hydrogen. This carbon picks up this whole segment. This carbon picks up this whole methoxy. Can I call that methoxy? Now what happens if I do that? CH3, COCH3. Everyone see that I'm adding them? Just like reduction. I already have hydrogen here. The single bond, double bond becomes single bond, OH. Everyone see this carbon now. This carbon is the one which contains ether, COC and COH. This carbon contains COC and COH. That's the reason why this is hemiacetal. That's the reason why this is hemiacetal. Now I'm going to add the second molecule of alcohol. Now I am going to add second molecule of alcohol. Because we know the first alcohol is unstable. Yes, the first alcohol is unstable. So what happens? I mean, hemiacetal is unstable. So it immediately grabs the second molecule of alcohol to form acetal. Now please look at here. I'm going to take the second molecule of alcohol. I'm going to write it here. Please look at here. This is my second molecule of alcohol. Now, if you guys are looking at the second molecule of alcohol, can you guys see the loss of water? We can remove water, OH from carbon and hydrogen from this. We can remove water. When you remove water, what happens now? This carbon has only 3 bonds, so this carbon picks up this fragment. So you will form. So once the water leaves, so what you get is this CH3 you guys can see that carbon is picking up that other OCH3 by losing water. Everyone see this? This carbon is picking up this OCH3 because this hydrogen is leaving with this OH as water. Now please look at this carbon. This carbon has ether, COC and COC. It contains 2 ether groups, so this is called acetal. So this is the whole mechanism how aldehydes or ketones are converted to hemiacetals and acetals. Now we are going to solve some problems. Page number 511. Try to solve 14.25, 14.26, 14.27, and 14.29. I just sent you guys a chat message. Page number 511. 14.25, 14.26, 14.27, and 14.29. So again, we are going to follow the same format. You guys are going to take 5 minutes to solve each problem, and then if you guys have any questions, I'm going to solve it on the whiteboard. So let's start with 14.25.
Hello, Moto.
Okay, any question on page problem number 14.25? Any questions on 14.25? Please send me a chat message. 14.25 A. If you guys are looking at A is neither. Why it's neither? It's just a ether. It's not hemiacetal or acetal. Why? Because all you see is COC. So A is neither. Please look at here. To be hemiacetal, you need to look at a carbon first. The carbon must, please look at the screen. The carbon must contain ether and alcohol. I don't see any alcohol on A. Carbon, you need to find one carbon that can contain ether and alcohol to be hemiacetal. And you need to find a carbon which contains ether and two ethers on the same carbon. So A is neither. Now let's solve C. There is no OH, ma'am. I don't know where you are seeing OH on A. I don't see OH. All I see is CH3, CH2, O, CH2, CH3. I don't see OH on the end in A. The most right, there is no OH. Look at your textbook, there is no OH. Oh, yours has it. That means in e-textbook, it's a printing mistake. E-textbook, there maybe it's a printing mistake. I'm looking at the hard copy, it doesn't have OH. I think it's supposed to be CH3. I think it's supposed to be CH3. If it has OH, then it is hemiacetal. If you have OH in the end, then it's a hemiacetal. If you don't have it, if it's in my textbook, I'm looking at it right now, it's CH3. So that's, if you have CH3, it's neither. Okay, now let's look at C. Now let's analyze this carbon here. If you're looking at C, let's analyze this carbon. This is COC. I see ether on it. And I see COC, ether on the same carbon. So C is acetal. This is ether. And this is ether. So C is acetal. (14.25) is acetal. Do you guys have any other questions on 14.25? Okay, now let's move on to 14.26. Any questions on 14.26? Do you need more time? (14.26) and D. So let's solve that. Now I'm solving 14.26B. I'm just drawing the condensed structure, line structure. Now look at this carbon. Look at that carbon. This carbon has OH, but this carbon doesn't have ether. Ether is starting from here, COC. This carbon has OH, but the problem is I have additional carbon that's breaking this. So this is neither. This is neither acetal or nor hemiacetal. Everyone see the problem with B here. If this oxygen is here, then it is hemiacetal, but the problem is this carbon. See, this carbon has alcohol, but this carbon is the one which has ether. They are not on the same carbon, so it's neither. Now let's solve E. E is also same problem. We have two ethers, but they're on two different carbons. They're on two different carbons. They're not on the same carbon. This ether is on this carbon. This ether is on this carbon. So it's neither. Any other questions from 14.26? Alcohol and ethers has to be on the same carbon, not on the different carbons. Now let's move on to 14.27. 14.27, you have 7 minutes to solve. Any questions on 14.27? Any questions on 14.27 and 14.29? A in what, ma'am? 14.27 or 14.29? The A is already on the screen right now. A is already on the screen. The A is already shown on the screen. 14.27A is already shown on the screen. For B, propanone. Okay, so you guys can see how I'm going to make this change to A. A is already on the screen. I'm doing 14.27B. Please look at 14.27B. I'm making this a ketone. Ketone and a ketone. That's it. Everything else is same. I'm not doing anything different. So 14.27B is on the board. All I am doing is changing that to CH3. Everything else is same. So the one that right now on the board is 14.27B here. This is 27B, and from here to here is 14.29B. (14.27). Now, what if I want to change this to 14.27C? All I have to do is what? Draw the same structure, butanol, and do the same process, ma'am. This area doesn't change. In every single problem, these areas are same. The rest of the chain changes. If you want to put butanol or butanone, it doesn't matter what you do, every single thing is going to be same. Now, this is the end of chapter 14. This is the end of chapter 14. Now let's do some additional practice problems. This is the end of chapter 14. Let's do additional problems. Page number 515. Those are the problems that you guys are going to solve right now. Page number 515. Page number 515, 14.41, 14.43, 14.45, 14.47, 14.49, 14.51, and 14.55. These are the problems that you guys are going to solve right now. Please start working on these problems. We are done with chapter 14. And if you guys have any questions, please let me know. I can solve these problems on the whiteboard. Page number 515. This is the end of chapter 14, and you guys are required to take chapter 13 exam and chapter 14 exam. And also you need to finish discussion activity 2 and discussion activity 3 before Sunday 10 p.m. Mm. Okay, any questions on 14.41 and 14.43? Do you guys want me to solve any problem on 14.41 and 14.43? Let's start with 14.41. If you guys don't have any questions, please send me a chat message. If you guys have any questions, or even if you don't have any questions, please respond to the chat message. So nobody has any questions on 14.41. Let's move on to 14.43. 14.43. Any questions on 14.43? Let's take 5 minutes on 14.43. Please try to solve 14.43. Okay, any questions on 14.43? Please respond on the chat. Even if you need more time, please respond on the chat. because everybody's timing, how much time they use to solve a problem is different. So I just want to make sure everyone is on the same page. Please let me know if you need more time or if you're done with 14.43. Okay, let's solve 14.43b. B is pentanol, all is aldehyde. That's the answer for 14.43. We have 5 carbons. We have 5 carbons. 1, 2, 3, 4, 5. Pentanol. Now let's move on to 14.45 and 14.47. You have 5 more minutes to solve those two. Okay, any questions on 14.45 and 14.47? Any questions on 14.45 and 14.47? Please send me a message. Please send me a message. Any questions on 14.45 and 14.47? Please send me a message. Very few people are responding. So nobody has any questions. If you have any questions, please send me a chat message. Okay, 14.7a. So the question is, between these two compounds, which one has higher boiling point? Well, clearly you guys can see this is alcohol and this is a ketone. Look at how I'm analyzing this by functional group. Alcohols, I can see here OH bond. If I see OH, that means what? It forms hydrogen bonding. So alcohol molecules are held together by hydrogen bonding and dipole-dipole interactions. We learned that. But if you guys remember ketone, yes, ketone doesn't have any OH or NH or FH bonds, but it has what? Dipole-dipole interactions because of carbonyl group. We looked at that in when we are looking at their properties. So clearly you guys can see alcohols contains hydrogen bonding. So alcohols contains higher boiling point than ketones. Move on to 14.49. 14.49. Please solve 14.49. So the answer is alcohol has higher boiling point than ketone. For 14.47a, alcohol has higher boiling point than ketone. Move on to 14.49. 14.49. You have to be specific when you send me the ABs, which ones you're talking about. 14.49b. Let's solve 14.49b. So I'm going to draw the line structure. So they gave us aldehyde, and they're saying oxidation. Please look at the general summary that I just talked about oxidation reductions. Please tell me if you have an aldehyde, if you oxidize, where it goes. Please look at the summary table that I just gave you guys. If you have an aldehyde, where it goes? It goes to carboxylic acid, if you guys remember. It goes to carboxylic acid. Please look at the table. So the carboxylic acid is this. I'm simply adding a oxygen. The number of carbons are exactly same. 1, 2, 3, 4. 1. After the reaction, I have the same number of carbons. 2, 3, 4. I added oxygen. Everyone see that? And this hydrogen is here. So this is the answer. Aldehydes converts to carboxylic acid.